So let's talk a little bit about how the current software architecture works. It's pretty complicated, so I'm going to go on a higher level than I usually do for this. So this slide is pretty daunting. It shows a lot of things, how CloudStack is currently built today. But I just want to focus on a couple of things. One is the orchestration engine. So really, this is where the smarts of CloudStack is. This is where most people, if you're going to commit code or contribute functionality to CloudStack, you're not going to touch the orchestration engine. Okay, this is where things like it drives where VMs are being created. For example, I want to deploy VM. This is what the orchestration will do. It'll take that command and start calling various what we call plugins now to determine how you want to create that virtual machine. So the orchestration itself just goes in each of the adapters or plugins and makes calls there, but it's not something that it's more like our kernel code. It's not gonna, that's something that you should almost never touch unless you really know CloudStack. So that's one aspect of the CloudStack architecture. What it does is it has a services API surrounding it. And these are the APIs that you should really be talking to if you ever wanted to make calls into the orchestration. For example, launching a VM or something like that, a generic example. What the orchestration engine does is it makes calls to the plugin API. So this is the API, for example, your network stuff. The previous question there. If you were to, for example, if I wanted to create a load balancer rule, today what will happen is that command will go from the UI to the end user API, down, it'll make a services API call to the orchestration engine. That engine itself will make appropriate plugin API calls now to the various customizable plugins you can insert into CloudStack. And then for each of these things, you can customize this yourself. And I'll go through some examples later on of what you can do in terms of plugin API. At the bottom layer, what we have here is our message or event bus. Today, the thing that uses this is, for example, for every action, major action you can do, especially resource creation, what you can do is, what it does is it generates events. And these events can be used to, for example, create resource metrics. So now you can determine, how long that might be. The other thing you can do is the communication between this orchestration engine and what we call our resources. So a resource in CloudStack is really a stateless Java piece of Java code. It really only translates between Java code and to any of the external devices or external components you want to communicate to. So a lot of the work, a lot of the custom work you may do, maybe right here, or within, if you know a little bit more, you can actually add your own plugin framework as well. So to answer the last question about network services provider, it's almost one of these resource files that you would create. You would say, here's a new Cisco resource provider. And all that does is translate any of the native, from Java to any of the native device API. And then lastly, what this kind of shows you is the orchestration engine may call additional management code out there. And some of these things could be from alerts to job, to resource, or even database access. So this is a very high level of how the CloudStack code works today. The very important thing I want to stress is the various API. The services API, which other components are on CloudStack can call. A plugin API, which is what the orchestration engine will call out to change its behavior. And then, of course, the communication between this engine and the resource files that are being called if we want to call it some type of external component that's not within CloudStack itself. And then, of course, at the very top there is CloudStack exposes all of this in its own web service API. So quickly going through orchestration again. Again, what I said for what the orchestration engine does is it really just is responsible for high-level pieces of commands. For example, creating, launching a VM, starting a VM, snapshot. It's really the same way. There's no deviation. right? You don't want to write code inside the orchestration and say, if VMware do this way, if KVM do this way. That's not where you want to write code. Eventually, what this will do is, for example, if I want to start a VM, it may go to a hypervisor group and say, hey, I want to create, given this set of data, are you the one that's supposed to be creating the VM for me? Right? So every command that gets sent down, the orchestration engine's responsibility is going out to these various plugins and asking, hey, I have this set of resources, this set of components, what should I do with it? Right? It itself is never going to be the one that decides this. It's going to ask someone else to decide for it. But what it does is it hands out and asks each question for each of the plugins you can go through down the chain before it executes that command. And typically, these are well-defined processes. For example, if I want to start a VM, I need to know which hypervisor is going to be on, where the root disk is on, et cetera, et cetera. And so that's what the orchestration engine does. And again, of course, it calls the plugin API to ask what it's supposed to do. The more interesting part is, what are these plugins? So the plugin itself ranges from a lot of things. So you can do things like change how a user can authenticate against CloudStack. You can change how VM can be allocated within CloudStack. For example, the way that CloudStack does VM allocation today, very good. Probably 3 or 4 different ways. Like out of the top of my head, one way is random. You can say for every time I want to create a VM, randomly pick a host, put it there. You can say first fit, find the very first host, put it right into it. You can say horizontally fit this and say just try to fill in each of the hosts equally amongst all of you. You can say anti-infinity. You can say for every account that comes in here, put them as far away as possible. Making sure that it's not the same host, it's not on the same primary storage, it's not the same cluster. Put it as far away. You have customers out there that say, look, by the way, I don't want a cluster of hosts, but everything to have. Right? You can also have what we call pod concentrating, which means that within a given pod, we will, because of the if you want something that has really, really low latencies, you don't want to go outside of your layer 2 switch, you can also have allocator that says, okay, for this account, put everything within this pod as much as possible. So we have different allocators that comes out of the box with CloudStack, but you can certainly customize your own and plug it right into it. It's as easy as implementing the interface, drop it in the job problem, adding it to the components that come out, and then it'll make it available as a choice for the user to select, or that user that configure the cloud. Again, the way that plugins are implemented is it has an interface that you have to implement, define that, and then all the calls are within a single transaction. Just to go a little bit further into what a plugin can be. So as I said, a plugin can be as simple as maybe one authentication adapter. For example, I want to, instead of doing a database comparison of my username and password, I could implement LDAP adapter. I know CloudStack already has one, you can certainly customize your own. It could be a single adapter, one adapter to be done. You can have plugins that are very, very, can actually extend beyond multiple interfaces. So for example, our OBS plugin today actually implements multiple of these plugins. It's not one. So you can get as pretty complicated as implementing multiple plugin interfaces that we have today. And I'll go through some of them we have. But it could be a combination of one and one. And you can also expose some of these features in your own API if you wish to use it yourself. So you don't have to rely simply solely on the CloudStack API. You can certainly expose your own API from your code and expose it out. And creating the API is pretty easy as well. You define there's an interface again that you extend, or a file, a class you extend. You extend it, implement it, and then I believe there's the file command properties. You can specify what command the REST command name should be, what file it's supposed to point to, and then who can access it. Either it's a user, it's a domain admin, or root admin. That can activate the API. What we don't have today in 3.0 is a UI environment. So you can expose it all the way up to your own web service API as an extension, very similar to OpenStack extension. You can do it yourself. But in the future, architecture will be allowing you to more easily expose even the UI component of that, so you don't have to manually type these commands yourself to configure. So an example of how we do this today is, for example, when you implement like a NetScaler provider for load balancer, you would implement some of the plugin interfaces or the server resources API. The problem is there is no standard API to configure NetScaler. So how do you do that? Right? You have to expose some type of custom API so the administrator of CloudStack can configure NetScaler, because we can't we may go with standard load balancer rules. That's pretty standard. But how you configure NetScaler is going to be different. How you configure Cisco, how you configure Arcadia, how you configure Yada switch, SRX, it's all different. So you're going to have to, at some point, create some type of admin API so that the administrator itself can somehow figure out what. The only other option is you tell them to manually do it themselves outside CloudStack. But in the plugin architecture, you're given the opportunity to add your own API itself, so it just comes right there. So quickly going through some of the plugin interfaces that we have today. And I don't know all of them, so I'm not sure I can answer all of them, but for example, the network guru is the one that really decides which of the network implementation is. So I believe this is the one that says whether it needs to use the layer 3 security group implement that, layer 2 VLANs or SDN networks. This is where you implement this. The network element itself is how do I implement each of the network, how would I implement each of the network services? So for example here, how do you implement load balancer VPN? These are rules that when I say I want a port forwarding rule or load balancer rule, these are the guys that says this is exactly how you would implement it within CloudStack. Deployment planner, I kind of went through that already. This is where you can customize where you want to place your VM. CloudStack already has multiple ways of doing this already, but you can certainly customize any way you want. What it does is there is an interface that tells you here are the various metadata information about what the user wants. You can choose however you want to allocate that. You can create your own deployment allocation. Investigator is a plugin where you can implement how we determine whether a host has really gone down or not. So, for example, when a host goes down, what happens today is CloudStack will try to attempt to figure out what really happened with that host. It could be as simple as going through a different host within the same cluster to do a ping to make sure it's alive. Whatever the case is, CloudStack is going to do something to make sure that when a host goes down, we really need to know whether it's down or not, because we don't want to start HAing or restarting these VM on a different host when they're already perfectly fine, right? We don't want to. We want to make sure that everything is that the user VM is really down before we do anything. Otherwise, you can get to scenarios where you have two VMs at the same time, right into the same disk, which is really bad. Fencer is another way of how you want to. This is part of the HA processing again. So let's say we determine that we want to live migrate VMs off from one host to another. Fencer is a way of saying, okay, how do I firewall these VMs from the rest of the cloud so that just in case that host really is still around there, we don't want to get to a situation where you have multiple VMs running on the same root disk and writing on the same disk. User authenticator, I went through that already. Again, the default one is some MD5 comparison against the MySQL database. If you want to write your own, I believe we have LDAP one as part of 3.0x. But you may have your own custom authenticator out there. If you want to write your own, feel free. We will give you the username, password, whatever data you need. You can just authenticate. Security checker is how we deal with ACL in terms of all the API commands. So you can implement your own. For every command that comes in, we already have a default implementation of how we should work. But if you want find your own way of doing this, you're welcome to do so. And I do know that currently it's not that good from what I've seen, but I do know that in the future we can clean up how all the ACL works. So we'll be given the opportunity to create more dynamic mode, because currently today in CloudStack we have static mode. We have the notion of a user, which is really just a user of the cloud. We have a notion of domain admin. But domain is really you can carve out pieces of the cloud and dedicate an area for one. For example, if I do a service provider, you can say for a reseller model, you can say here's part of the cloud. You can manage it yourself, and that is what a domain is. That you can manage all the virtual resources and users for that domain. And then, of course, the last use is the root admin, which has everything that anyone can do, plus all the APIs that access the physical resources. But in the future, what we want to do is clean up that security tracker so that you can create dynamic hosts now, much more easier than you can do today. Host allocator, just different ways of adding hosts into CloudStack, and then storage is different ways of adding storage or configuring storage in CloudStack. Probably more than what's listed here, but at least these are the major ones that we have today. Right. So what I want to do is, should we take a break here?
ちょっとですね、休憩を取ります。休憩の前に、質問タイムにしましょうか。そうです。
I'll do a little Q&A session as well, what I just talked about. So if you have any questions on what I talked about in the class session,
今終わっています。
すみません、先ほどちょっと質問し損なったんですけど、SDN をサポートするということなんですが、クラウドスタックにおけるインタークラウドというかの取り組みっていうのはどうなっているのかっていうのをちょっとお聞きしたいです。インタークラウドっていうのは一機種間のクラウドの接続方法でご存知だと思うんですけど、例えばDMTF とか世界的な地方力団体で、SDN の広域網を作って、その広域網の中にクラウドも、リソースとしての雲として浮かべて、接続するような構想があったりとかするんですけど、クラウドスタック側としてはどういう構想を持っているのかっていうのをちょっとお聞きしたいんですけど。
I'm not sure I got all of your question. I think that actually the vision about the future CloudStack and how we want to do SDN, I think that's something that Shane will present next. So we can certainly ask Shane because I agree with you, there is some components of the CloudStack today that makes it a bit hard for contributors to contribute against the CloudStack. And so what I want Shane to talk about is how we plan to make that easier and how we envision using SDN to be forward in CloudStack. So let's wait on Shane for the presentation and certainly that may go and answer the question. Anyone else before we take a break?
最初のストレージの方の話なんですけども、プライマリーストレージで、それなりにパフォーマンスをストレージを用意した方がいいとおっしゃったと思うんですけども、大体どれくらいの、規模に対して、どれくらいのパフォーマンスがいいかっていう、具体例じゃないけど、数十台規模であれば、それこそ、普通の Linux の、サーバーに NFS を送っていたけども、数百台 だ規模になったら、それこそ EM、あ、すみません、数十台規模であれば、NSX とかのサーバーで、普通の、IBM とかのサーバーで OK かもしれないけども、数百台、数千台であれば、それこそ EMC とか、デカップとかを用意しなきゃいけないとか、ちゃんとしたアプライアンスを用意しなきゃいけないとか、その辺のなんか規模感的なものがなんとなく分かればありがたいんですけども。
So I don't know the specific numbers of how the number of compute nodes in primary storage. I don't have that number off the top of my head. But what I can say is when I talk about primary storage, I meant that you could have multiple, you give the opportunity to have multiple tiers of storage you can configure within a given cluster. And what I mean by that is for one primary storage, you could, for example, have a commodity disk, right? For a different one, you can have big EMC storage as well. And if you configure them differently for the cluster, what CloudStack gives you or gives the admin opportunities to create service or disk offering, so that when you create an EM, you can now target which of these storage to put it to. Now I know your question is do you have any numbers to say for 10 hosts, how big of a storage? I know we have that somewhere within CloudStack. I just don't know off the top of my head what exactly, and then I'm sure it differs between the different hypervisors as well, between Zen server, KVM, and VMware as well. So I apologize, I don't have the exact answers for that one, but I do know that we have that there somewhere in terms of white paper or some type of architecture. So the worst case, I would try to find that out. It may actually be in our wiki website somewhere as well. Probably trying to figure out what that is exactly. Any other?
On your first slide in this section, is there any reference or documentation of quantum interface?
Oh, quantum?
CLI, command line interface.
Oh, we have in CLI. Oh, I know we have one in 2.2, but I'm not sure we refreshed that for 3.0. It's something that I think Apache CloudStack community to read. But I do know the 2.2 one, CloudStack had an old CLI tool that basically made it their off. We actually have one for testing as well, but I'm not sure if that's exposed as something that the community is something. I'm not 100% sure, but I know we have it. We definitely have a CLI tool because our testing framework uses that tool.
Okay.
Any more questions?
I'm
asking one shirt.
So I'm asking because you mentioned quantum, so
Is quantum in it? No, it's not.
Yeah. So any plan of supporting quantum as an abstraction layer or?
It is possible. We continue. Other than OpenStack Nova, that one is a direct competition of the CloudStack does. But for example, Swift, Branch, Keystone, Quantum, I think with all of these other components that OpenStack has today, the CloudStack, the top platform, will definitely look at that. Even the open source will definitely look at that and say if it fits well in the architecture, we would definitely implement it. I mean, for example, Swift, we weren't implementing that because it's a piece that is easily added to CloudStack. So to answer your question, yes, we don't do anything quantum today, but we are actively looking at quantum to make sure. The thing is, the way that we build our network, CloudStack already has their version of what quantum does, and it's actually ahead of what quantum is today. So we don't want to go backwards right now. If quantum matures to the point where we believe that it's very useful for CloudStack, we will definitely think about it. Any other questions?
Well, sir, thank you very much for your explanation. So last week I happened to hear about some feature of the open cloud, right?
Open cloud.
Yes. So what's the difference between OpenStack? What's the difference between OpenStack and CloudStack?
Wow, that's a good question. So I think the question is really pretty broad. It's like, what is the difference between OpenStack and CloudStack? That's your question. So I can go a little bit about the differences there, but if we talk about OpenStack Nova, right, that is the controller that controls the compute resources. That is very simple. That's almost a direct competition with CloudStack, what CloudStack is. The differences between the two projects, so other than the fact that CloudStack is much more mature, so I can say that CloudStack has been around maybe a year and a half before even OpenStack came about. Architecture-wise, OpenStack written in Python, CloudStack is written in Java. There's a difference there. What else is the difference? In terms of what I talked about earlier, the way that we can support the different workloads. So for example, I talked about there's the server virtualization, server plus model, which is workloads or applications that really depend on the existing infrastructure. That's something that OpenStack does not do really well today. That's what VMware does really well today. And then other side, what OpenStack compute or the OpenStack Nova wants to do is more of in the cloud, Amazon-like infrastructure, and that is what CloudStack does today. The difference is CloudStack actually can do both. So that's the fundamental difference. Another big difference that CloudStack has over OpenStack is just if you think about it in today's market, I don't know what the exact number is, but a lot of service providers, whether it's public cloud or even private clouds, a lot of people using VMware, and you have built a lot of applications that does require the infrastructure. It just can't fail. You can't assume that a hardware will fail. They are applications that really require something like 5 nines, really, really robust, reliable hardware. And while CloudStack and Citrix believes that we will eventually migrate to the cloud architecture, we're not going to sit behind and say, oh, well, no one's going to, we can't leave the other 80% or whatever the big portion of the applications out today. And so when we design CloudStack, we ensure that we can do both, right? Not only is it hypervisor agnostic, but it can support both types of applications right now. In terms of I can only go with kind of the facts. I would say that OpenStack definitely has a bigger marketing momentum than we have. But just from when Citrix acquired Cloud.com, we did go through a heavy technical review about both products. As you know, Citrix is one of the founding members for OpenStack. When they acquired Cloud.com, they had to make a decision of which one to choose. And we did a really long technical investigation between both. And maybe you guys have played with it too. It's just OpenStack is almost a year and a half away from being ready. We have over 100, CloudStack over 100 production deployments out today. I don't even know how many OpenStack has. It's maybe more than 5. I really don't know. But I can tell you from personal experience, OpenStack, when you install, from the moment that we installed CloudStack on the production cloud, there was a lot of features, a lot of fixes that we put in that you can never know unless you're in the production cloud. Okay, so adding features, adding things surrounding plugin architecture, that's all good. But if you really want to do a real business out there today, you will find out when you're in a production cloud and something fails or you need to fix it. A lot of the work that we have done today that's part of CloudStack, it's really, at this point, it's almost 50-50 in terms of what we believe should be in CloudStack. And the other 50% is pretty much what we have learned when it's in production. Right? Our support, in engineering deals with a lot of support. What I tell my team to say, listen to the support right now. There's a P1 failure. What do we do about this? And when you design features and stuff like that, you may think about you want to do this, but in reality, when it really hits you, when you actually get that call and say, look, my VM's down, I can't do anything. Customer is screaming at us as we must fix this right now. Then you're going to change the software to do a certain way. Your priority will instantly change. Feature does not even matter at that moment, because what you want at that moment is make sure that VM or that cloud is up and running. And so even if OpenStack, just in the architecture, even if OpenStack does get to that point, I still believe that it will have some type of learning curve when it gets to production cloud framework. And so there, I do believe even as simple, I'll just take one feature really simple that we didn't even think about, was when you add a zone. It's really simple here. When you add a zone into the cloud, when we launched it first, we just said, yeah, no problem, we just add a zone. What we didn't realize is what happens when you have to add the second or third zone. And one of our customers added right into it, and it instantly became available to everybody. Right? So now we just realized, oh, okay, now we have to add states now within that zone and say, okay, we're going to add a zone, make sure that state is as simple as do not make it available so everyone can see it. We want to test it first internally before we make it publicly available to everyone else. So even very, very simple things like this, you don't realize unless you're in the production cloud today. And I think even with that, OpenStack needs to, I believe that it needs to go through that process before. Now, I'm not saying that OpenStack is bad and it's going through the same kind of growing pains that CloudStack did. But it's two different architecture. I think OpenStack it's more modular architecture than CloudStack. Which is one of the reasons why Citrix decided to push it, donate the CloudStack project to Apache, so we can leverage people like you guys to help contribute new features from CloudStack, help us define how we should do with networking or architecture today. And Shane will talk a little bit about that more. And if you guys, we would be most welcome for you guys to come in and help us make the architecture better than what it is today. So we've already done a lot of, Citrix has done a lot of great work to making sure that the CloudStack project is a real platform, is a real product. And now we're at a stage where we believe that anyone adding in, we can still deliver the quality that we have in CloudStack today. It's a mature product, we still deliver that quality. And then also giving your contribution to making a better product than what it is today. So hopefully I can answer that question. Again, it's a very broad question, so that's I can't explain that. Okay, anyone else? Okay, so let's. Good. I like questions.
今持っていきます。
Oh. So you want teachers? Yes.
一つのクラスターで特性が違う、ストレージを複数マウントすることは可能ですか？
Okay, is it possible for me to have different storage? Storage, is different in terms of which characteristics, and we have those multi-storage have different
Yes.
within one cloud.
Yes.
また、
One more.
インスタンスからその使うストレージを選ぶことができますか？
Whether or not can I choose specific storage for me to use for instance?
Yes, you can do that too. That's what I was talking about. It's not even per cloud, you can do it per cluster. So with a given cluster, let's say VMware, or let's say Zen server, you can have one primary storage that is, let's just say an SSD, very fast disk. You have another primary storage, which is some SATA disk you buy from your local store. You can have two different types of primary storage. The admin administrator can create a disk offering that says, when you select this disk offering, create your disk volume on primary storage 1, which is fast. You can also have another disk offering that's cheaper. Let's say create your disk on the slower primary storage. So to answer your question, yes, it's not even per cloud, it's per cluster. So you can customize it.
Another question, if I may.
クラスターをまたいだ VLAN の設定はできますか？
Can I set up VLAN between clusters or among clusters?
In terms of the guest network, you have to make in terms of per zone, you have to trunk in all of the, for example, if you're going to use the layer 2 isolation, you would have to trunk in switches, all the pods for one zone. You do have to do it. You have to, yes, you have to. If you wanted to use the layer 2 isolation, you have to truncate for each switch. You have to truncate every single event to that. Now, if because I was going to think there is another network today. It's still layer 2, but you can create what we call a shared guest network. So the administrator can select the event and say, for this network, assign event 100. And make it available for everyone to create, to put their VM on it. But again, that 100 network event needs to be put in every single switch, every single pod in that zone. Any other questions for?
すみません、一点ご質問なんですけども、プラグインでですね、クラウドスタックによる機能を追加できるという話だったので、例えばですね、ハイパーバイザーで動く VM のリソースの状況というものをマネジメントからですね、見るといったプラグインというのは、例えば Amazon でいうとクラウドウォッチみたいなサービスがあるんですね。リソースや攻撃にかける API とかっていうのが実装されているかどうか教えてください。
I don't know exactly how Amazon does it, but I assume there's really a couple of ways you can monitor. One is actually within the VM itself, something like yesterday, or by what the hypervisor reports today. Maybe there might be another way as well, but certainly you can add this today, but I'm not sure there's a specific plugin in CloudStack today that says you can implement this and then monitor whatever CloudStack has. I don't think there is a plugin of that specific nature today, but it is something that we can probably add in the future if you wanted that kind of capability. And I assume for your case, you want something that's not an agent within the VM itself, it's something external outside. But yeah, I don't know there's one specific plugin that does that right now. That might be something that we can certainly help contribute and add to CloudStack. Any other questions? Break time?
One more.
Right there.
2つ質問させてください。V ルーターですね、バージョンルーターのところが次のバージョンで、かなり、機能アップするということなんですけど、その、ハイパフォーマンスになったときにどういうふうにリソースを割り当てるのかなと。例えばあるテナント向けのバーチャルルーターを非常に機能を、使いたい、例えばダイナミックルーティングを使いたいだとかっていうのに対応するには大きなリソースがいると思いますし、簡単なテナントについては少ないリソースでいいといったような形もあると思うんですけど、そういうようなことってすることができますか？
Okay, so right now you can so the network offering. The network offering. This actually applies to a virtual cloud as well. So I didn't list all the features here, but you can certainly create for one customer, take one network offering that. I'm sorry. The network, for a virtual router, you can have network offering. You also have a compute offering. So you actually can change the size of the virtual router itself as well. So for example, one customer, very small, you can say create a compute offering for that virtual router and say it only requires 4 gigs of RAM, 2 core CPU. That's it, nothing more. And you can break that virtual router as well. On the other hand, you can go to a different customer that says I want something much bigger. You can add for that particular virtual router, you can assign a compute offering and say this is going to take 128 gigs of RAM, 16 core CPU. You can definitely do that as well. And then last thing you can do is, okay, if there's no way that a virtual appliance is going to be able to handle the load, then let's start moving to the next scaler or physical appliance as well. So yes, you can definitely control the different, for each customer, you can control exactly how large you want for the virtual router and the ability to change the different network providers.
する質問が、例えばパケットレベルでのトラフィックを見たいってなった時に、そういうの API とか、プラグインみたいなのが用意されてるとか、作らなきゃいけないとか、分かるようにしてほしいですけど。
Yeah, currently today, unfortunately, we don't have an API that you could inspect the individual packets. I think that's something we'll have to add custom. What we do is we do track the input in, the bytes in and out from the public network. So we don't track bytes within guest VMs inside the virtual network. Like between the guest and the public network, we do track just only bytes in and out. That's it. Like if you want to go more deeper into number of packets, all that stuff, that's something that you have to custom make.
ありがとうございました。
I think there was one more question. So.
プラグインについてなんですけども、クラウドスタックにデフォルトでついてくるプラグインを入れ替えたりとか、クラウドスタックデフォルトの動きをフックするような、プラグインが可能なんでしょうか。
Okay, so whatever the plugin API is, you could change it. The problem is if you change the API, that means all other implementations of that API will be broken at this point. So it's not really highly recommended that you change the API. You can certainly ask to, for the Apache CloudStack, you can certainly say we want to extend it to the API. That's definitely something you can do. So changing the existing API is a really bad idea. You can definitely extend it. Now, the other part to it would be our implementation of the plugin. Now, the implementation itself, you can something change it and extend it, create your own version, add it to CloudStack Power, or suits you.
はい、ありがとうございます。
VM と、クラウドスタック内の VM と外部の物理サーバーをレイヤー2で接続したいんですけど、それは可能でしょうか。
Yes, you can. So within CloudStack today, first, number one, each VM you can connect to more than one network. Really depends on the hypervisor itself. I don't know the exact for Zen server and I think like 6 to 10, and I don't know the specific for each hypervisor. But each VM can connect to multiple networks, and the network itself could be something that CloudStack creates. For example, it could be a virtual guest network that we have today, which is an isolated network just for that account. The administrator could create a layer 2 network, let's say backed by a particular VLAN, and say and dedicate it to a particular account and say, here's VLAN 100 for you. You connect your VM to this VLAN 100. I will connect the other side of that network to using MPLS, whatever you want, to your external. It could be a server, but typically it's an entire company. That's not even in the same data set itself, right? So you have the flexibility. The admin has the flexibility of creating these layer 2 networks that can bridge between any VMs or any network that you have created inside CloudStack and anything outside. But the outside part is going to be something the operator will have to do themselves. It's not something that CloudStack will do. What CloudStack will do is we will ensure that layer 2 network is available for the user to select what their VM on.
その場合はバーチャルルーターを完全にバイパスするような動きになるでしょうか。
Yes, yeah, that's what I'm saying. That shared network, the VLAN 100, does not have to go virtualized. You can configure, do whatever you want. You don't have to.
ということは、そのバーチャルルーターでの接続のその L2 スイッチで、個別に VLAN を割り当てて線を引けばいいということですか。
I'm not sure I really understand, but if, for example, you want to add your layer 2 specific network, let's say you VLAN 100, you would have to configure the switch to say VLAN 100 goes to this switch, and all the switches within that that zone. And then in CloudStack, we would say VLAN 100 is make it available. Either you can make it publicly available, everyone can connect it, or you can say for this account, you can see this network and put it on. So yeah, you do have to configure it as part of the switch. Now, the virtual router events is separate. In the virtual router case, what we use layer 2 is we would trunk in a whole bunch of non-routable VLAN right into each switch, and CloudStack will pick one of those VLAN randomly and assign the guest network to that. But we will do that for you. For the specific case you're asking, you can make that separate outside of the VLANs that can be chosen by CloudStack for the individual network. You can put it outside. You can still configure the switch.
はい、ありがとうございました。